Now let us cover some concepts related to triangles. So triangle is a geometrical shape with 3 points connected together. So if we have 3 points A, B and C and we connect them, we get a triangle. And when we connect these 3 points, 3 angles are created inside the triangle. The sum of these 3 angles within a triangle is going to be 180 degree always. So this is a very important rule. This is going to be used in every question which includes a triangle. Sum of all the angles in a triangle is 180 degrees. Then there is a special case of a triangle where all the 3 sides are equal and all the 3 angles within the triangle are equal. This special triangle is called an equilateral triangle. So when we say that we have an equilateral triangle, there are 2 things we know. First is that all the 3 sides are equal, and the second is that all the 3 angles are equal. And if all the 3 angles are equal and the sum of 3 angles is 180 degrees, so individual angle is going to be 60 degrees. Another special scenario is when instead of all 3 sides, only 2 sides are equal. When these 2 sides are equal, the opposite angles are also equal. So these 2 angles which are shaded yellow here, these 2 are going to be equal. Then a third scenario is called a scalene triangle where no 2 sides are equal. So the dimensions of all 3 sides are different. No 2 sides are equal. Then there is another rule. This rule says that sum of any 2 sides is greater than the third side, and the difference of any 2 sides in a triangle is less than the third side. Sometimes when we have to find a side of a triangle, this rule can help us rule out some of the options. So if you know the 2 sides, you can get a limit of what the third side is going to be between. So you can subtract those 2 sides to get the lower limit, and you can add those 2 sides to get the upper limit. And this can help you in eliminating few of the options. The last property written here is that the hypotenuse is a side opposite to the right angle. So this right angle triangle is a special scenario. In this triangle, one of the angles is 90 degrees. In this triangle, 2 sides between which the angle is 90 degrees, these 2 sides are called perpendicular and base. So here BC will be called base and AB will be called as perpendicular because it is at 90 degrees with the base. And the line which is opposite to this 90 degree angle is called hypotenuse. And in a right angle triangle, there is a special relationship between these 3 sides. This relationship is called Pythagoras Theorem. And this relationship is that hypotenuse square is equal to sum of squares of the 2 sides. That is AC square is equal to AB square plus BC square. So if you see a right angle triangle anywhere in the question, this Pythagoras theorem should come to your mind that you may be using this to solve that question. Hypotenuse square is equal to sum of squares of other 2 sides. Now whenever we get questions related to triangles, often there are additional lines drawn within those triangles, and these lines can have certain properties. For example, if we create a line which is perpendicular and it is bisecting one of the sides of the triangle, so this line is a perpendicular bisector for the base of the triangle. If you create perpendicular bisectors for all 3 sides, such as we see in this diagram, the 3 perpendicular bisectors will meet at a point called P. So the first scenario is if the line that we create is perpendicularly bisecting one of the sides of the triangle. So the line that we have drawn here, this is bisecting the base and it is at 90 degrees with the base. So this is a perpendicular bisector line. Another type of line that can be drawn in a triangle is an angle bisector. So this was the whole angle, and we have drawn a line which is dividing this angle into two equal parts. So this is an angle bisector line. Then we have median. So median is a line from one of the vertex. It starts from one of the vertex and it meets at the center of the opposite line. So you can see the difference between perpendicular bisector and median. Perpendicular bisector also is at the center of the opposite line, and median is also at the center of the opposite line. However, median starts from the vertex and perpendicular bisector may or may not reach the vertex. It is perpendicular to that line. And then there is another scenario where the line is perpendicular to the base and it is going to the vertex, but it may not be dividing the base into two equal parts. So this is perpendicular and it is starting from the vertex. So such a line is called altitude. Now in all these four scenarios, if we create these lines on all the three sides or from all the three vertices, these lines may intersect at a single point, and these points have special names. For example, in the first scenario, when we are creating perpendicular bisectors for all the three sides, then that intersection point, which is denoted here as P, this intersection point will come. This point is called a circumcenter. Now the circumcenter has special properties which we will discuss in the next slide. You must remember that circumcenter is the intersection of three perpendicular bisectors. Then the intersection of three angle bisectors is called an incenter. So this point Q here, this is an incenter. Then for three medians, if we create three medians and they intersect at this point is called a centroid. So here this point R represents the centroid of this triangle. The special property of a centroid is that the centroid will divide the median in a ratio of 2:1. So BR is to RD is going to be 2:1. Similarly, if this point is E, the ratio of CR to RE is also 2:1. So the special property of a centroid is that it will divide the median in the ratio of 2:1. The fourth scenario where we had altitudes, if you create three altitudes from the three vertices, you will get an orthocenter. This point S is called an orthocenter. Now let us look at the special characteristics of these circumcenter and incenters. Now the first diagram that you see on the right, that is showing a circumcenter. So we have drawn perpendicular bisectors on all three sides. So for side AB, the perpendicular bisector is OD. For side AC, the perpendicular bisector is OF. And for side BC, it is OE. All these perpendicular bisectors are intersecting at O. Now the property of O is that it is equidistant from all the three vertices. That is, distance of O from A, B and C is same. So AO is equal to BO is equal to CO. Now since all these three are equal, we can take O as a center and create a circle with the radius AO, and that circle will pass through all three of the vertices. So the property of circumcenter is that it is equidistant from the 3 points, and you can create a circle which will inscribe, which will pass through all the vertices, and the triangle will be inscribed inside the circle. You can look at this in a different way also. So in a question, if you get a triangle inscribed inside a circle, you would know that the center of that circle is actually the intersection point of the perpendicular bisectors. So if you drop any line from that center to any side of the triangle, that will be perpendicularly bisecting that triangle. So when we create a circle using the circumcenter and joining all the three vertices, that circle is called a circumcircle and the center point is called a circumcenter. The radius of the circle is going to be circumradius. So the terminology is simple. Everything related to perpendicular bisectors will be written as circumcircle, circumcenter and circumradius. The next scenario was related to incenter. So in a triangle, when we create three angle bisectors and they are intersecting at a point I, this point is called an incenter. Now this point is equidistant from the three sides of the triangle. That is, if you create a perpendicular from this point to any of the three sides, the length of that perpendicular is going to be same. And if you take that distance as the radius and you draw a circle, you will get a circle inscribed inside that triangle. This circle is called an incircle and the radius is called inradius. So this circle will be touching all the three sides of the triangle and all the three sides of the triangle will be acting as tangent to this circle. That is, the angle made at the point they are touching will be 90 degrees. Now comes the concept of similar triangles and congruent triangles. So similar triangles are triangles which have same angles. So their dimensions may be different, but their shape will look similar. The three angles of those triangles, all three angles will be same. One may be larger, one may be smaller, but angles will be same. If all the three angles are equal for two triangles, then this particular relationship holds. That is, the ratio of their sides will be equal. So AB by DE is equal to BC by EF is equal to DA by FD. So if we know that two triangles are similar, how will we know that? If all the angles in two triangles are same, then those two triangles are similar. If angles in two triangles are similar, then we can use this relationship that their sides are going to be proportional to each other. Another important theorem is, this theorem is called angle bisector theorem. So if we have a triangle and we draw an angle bisector from one of the vertices, this angle bisector will reach the opposite side, say at point S. So this PS is the angle bisector and it is intersecting with the opposite side QR. In such a scenario, there is a particular relationship between the sides. This relationship is this: A is to B is equal to C is to D. So the ratio of the two sides of the triangle is equal to the ratio in which the angle bisector is cutting the third side. So whenever you see that there is a triangle and there is one angle bisector, remember this theorem that A is to B is equal to C is to D. Then there are congruent triangles. Congruent triangles are two triangles which are exactly same. That is, their angles are equal and their sides are also equal. So AB is equal to ED, BC is equal to EF and AC is equal to DF. All three angles are equal, all three sides are equal. So their orientation may change, but the two triangles are exactly same. Their area is same, their perimeter is same, everything, all their characteristics are same. Now when we have closed shapes, we can find the area enclosed within those shapes. So triangle is a closed shape. The area of a triangle is denoted by this formula. Area is equal to half into base into height. So you can take any of the three sides as the base, draw a perpendicular from the opposite vertex to that base, and find the multiplication of half into base into height, and that will give you the area. So here you can see that we have taken the bottom side as base. So if I take the right side as base, I draw a line perpendicular to that base. So now the area of the triangle is going to be this base and this height. Base is not that point. So base is till this point only. Base is not till this point. Base is this length only and height is this length. And you can multiply these values and you will get the same area. So you can take any of the sides as base, draw a perpendicular to find the height, and multiply it with half to get the area. There is another way to find the area of the triangle, and that is using semi-perimeters. So perimeter is basically sum of all sides of the triangle. So perimeter of a triangle is A plus B plus C. Semi-perimeter is half of that. So S is equal to A plus B plus C by 2. If you know the three sides of the triangle, you can find the semi-perimeter first and then put that value into this formula. Under root S into S minus A into S minus B into S minus C. This way you will also get the same value of area. This formula is called Heron's formula. So if you do not know the height and you have three sides of the triangle, you can straight away use this formula. Else, you can use the half base into height formula. Now let us look at some examples so that we understand the concepts. In this figure, we have to find out the sum of all 6 angles on the vertexes. So this angle plus this angle plus this angle plus this angle, E and F angle. Focus on this image and you can see that there are two individual triangles. One is this triangle ACE and the other is this triangle DBF. So this shape is created by these two triangles. The sum of angle ACE is equal to 180 degrees. We know that the angles within a triangle add up to 180 degrees. Similarly, angle DFB is equal to 180 degrees. And we want to find the sum of these two. So the total angles is 360 degrees. So although the shape looked complicated, but it was just made by joining two triangles and we easily found out the sum of all the angles. Now in this triangle ABC, there are two angle bisectors. So OB is bisecting the angle B and OC is bisecting angle C. We know that angle A is 70 degrees and we want to find out the value of angle BOC. So I'm taking OBC as X and angle OCB as angle Y. Now X, so this angle is also X. Here this angle is Y because OB and OC are angle bisectors. Now if I look at triangle ABC, the sum of angles is going to be 180 degrees. So 70 degrees plus 2x plus 2y is equal to 180 degrees. And we want to find out the value of angle BOC. So angle BOC plus x plus y is equal to 180 degrees is what we know. Angle BOC plus x plus y is equal to 180 degrees. So we want to find angle BOC. If we know the value of x plus y, we can substitute it here and find the value of angle BOC. And we can find the value of x plus y from the first equation. So 2x plus 2y is equal to 180 minus 70, so 110 degrees. So x plus y is equal to 55 degrees. We can replace that here. I'm going to find that BOC is equal to 125 degrees. So we do not need to find individually what is the value of x and what is the value of y. In both the equations, we only wanted x plus y, and we got the value of x plus y from the first equation. In this question, angle QPR is 90 degrees. So angle QPR is 90 degrees. That means triangle QPR is a right angle triangle. QR is equal to 26 centimeter. PM is equal to 6 centimeter. So this line is 6. MR is 8 centimeters. Angle PMR is 90 degrees. We have to find the area of MPQR. That is this area. So to find this area, we have to first find the area of triangle PQR minus area of triangle PMR. This is what we want to get. This is the area MPQR. So area of triangle PQR is half base into height. Base is PQ, height is PR, PQ into PR. Now area of triangle PMR is equal to half PM into MR. Now in the question we are given the value of PM and MR. So this we get as 24. Now PQ and PR are not given. But first let us look at the triangle PMR. We know PM, we know MR, and there is a right angle between them. So we can apply Pythagoras Theorem to find the side PR. PR square is equal to 6 square plus 8 square. So this comes out to be 100. PR is equal to 10. Now triangle PQR is also a right angle triangle. So PQ can be found out using the same Pythagoras theorem. QR square is equal to PQ square plus PR square. PQ square plus 100. So 676 minus 100 is equal to 576. So the root comes out to be 24. 576 is a square of 24. So PQ comes out to be 24. So now we know PR and PQ also. Let's put that in that first formula. And half into 10 into 24. So this comes out to be 120. So 120 minus 24 is equal to 96. So using the Pythagoras theorem, we can find out the sides, and using the formula for area, that is half base into height, we can find out the areas. So these are the concepts related to triangles that we must remember. Now let us look at some of the questions related to triangles that we see in competitive exams. Now here we are given that there is a triangle ABC. AD is a bisector of angle BAC. So this angle BAC is divided into two equal parts and it is labeled as X in the diagram. Now AB is given as 8 centimeter. BD is marked as 6. CD is 3. So obviously this diagram is not to scale, but anyway we are getting the idea. Now we have to find the value of AC. So whenever in a triangle we see an angle bisector, we should be reminded of the angle bisector theorem. This we discussed in the last lecture, in the last video. And the angle bisector theorem said that if we draw an angle bisector from one vertex to the other side of that triangle, that angle bisector will divide the opposite side in the proportion of the two sides of the triangle. So ratio of BD upon DC will be equal to AB upon AC. So we just have to write this equation, BD upon DC is equal to AB upon AC. So this is from the angle bisector theorem. We know three values here. We know the value of BD, DC and AB. And we can straight away find the value of AC, which will be 4 centimeter. So you can take the option A. So whenever you see an angle bisector in a triangle, always remember that there is an angle bisector theorem which you can use. In this diagram, PQ is equal to QS. So if you're looking at this triangle PQS, this is an isosceles triangle, which means this angle at P is also equal to the small angle PSQ. Second thing given is QR is equal to RS. So these two sides are also equal. So if we look at this triangle SRQ, these two small angles will also be equal. And we are given that angle SRQ, this angle, is 100 degrees. Now we have to find out the degrees in angle QPS, this small angle. What is this value? So first let us look at this small triangle where we have a value. We have this value of 100 degrees at angle R, and we know that this is an isosceles triangle. So we can easily find out the value of these two angles. Since this is an isosceles triangle, these two angles are equal. Angle SQR and angle QSR. These two are equal. So if we just take them as x, so 2x plus 100 is equal to 180. Since the sum of all the three angles of a triangle is 180 degrees. So that is where this equation is coming from. This gives us that x is 40 degrees. Now we know that this angle is 40 degrees. If you look at point Q, the whole of the angle on one side of this line is going to be 180 degrees. So we can find the rest of the part of the angle, which is angle PQS. Angle PQS is equal to 180 degree minus the 40 degrees which we have found earlier. So angle PQS is 140 degree. Now we will focus on this other triangle, triangle PQS. In this triangle, let us take this angle as Y. If this is Y, this angle is also Y. Because this is an isosceles triangle, we know that PQ is equal to QS. So the opposite angles are also equal. So Y plus 140 degrees is equal to 180 degrees. We can solve this equation and get Y is equal to 20 degrees. So starting from the part where we know some value, we will reach the point where we have to find the value. Now in this figure, we are given that AD is equal to DC is equal to BC. So these three sides are equal. And we are given the value of angle BCE, that is also marked in the diagram. It is 96 degrees. We have to find the angle DBC. DBC, this angle. Now let's start from one corner. Let's say we are taking this angle as X. Now since this is X and these two sides are equal, then this angle is also going to be X. If this is X and this is X, this is going to be 180 degrees minus 2X. If this is 180 degrees minus 2X, the remaining angle on point D is going to be 180 degree minus 180 degree minus 2X. So this is going to be 2X. Also note here that whenever we have an exterior angle forming on any vertex of a triangle. So suppose our original triangle was ACD. if this was the triangle and we extend one of the edges at point D, which is going towards point B. Now this angle, which we have marked here as 2x, this angle is called an exterior angle of a triangle. The exterior angle of a triangle is equal to sum of opposite interior angles. So since it was x and x here, the exterior angle is 2x. Even if this was x and y, the exterior angle was going to be x plus y. So whatever are the opposite interior angles, exterior angle is sum of those two opposite interior angles. So that is also a property which you can remember to make your calculations faster. So right now we have reached this point where this angle is 2x. Since the two sides are also equal, DC is equal to BC, therefore this angle is also going to be 2x, which means that this angle is going to be 180 minus 4x. Now we have the three angles on a side of a line. So this angle is x, then we have 180 minus 4x, then we have 96 degrees, and the sum of these three is going to be 180 degrees. Let's write this equation. X plus 180 minus 4x plus 96 is equal to 180 degrees. Now we can solve this equation to find out the value of x. So 3x is equal to 96. X is equal to 32 degrees. Now we have to find the angle DBC, which is 2x. So we know that x is 32, so 2x is going to be 64 degrees. So this is how you can solve this question. You can simply use the concept of exterior angle also to solve this question. So since we have labeled this diagram, this angle is x degrees, this angle is 2x degrees. And if you are looking at the triangle ABC, this 96 degrees is an exterior angle. And exterior angle is going to be equal to sum of interior angles. So 96 degrees is equal to x plus 2x. So you straight away get the value of x is 32 degrees. So you can solve this question in both the ways. You can save few seconds if you remember that an exterior angle is equal to sum of interior angles. Now it is given that ABC is an equilateral triangle and D is a point on BC. So on BC we have D and AD is perpendicular to BC. Now in equilateral triangle, since all the three sides are equal, a perpendicular from one vertex to other side is also the perpendicular bisector. It is also the angle bisector and it is also the median. So it is a special property for equilateral triangle that if you draw any one of the four things, it is the same. The median, angle bisector, perpendicular and the perpendicular bisector, all four are the same in an equilateral triangle. Now if all of these are same, if you make all three, that is if you make the three perpendicular bisectors or if you make the three angle bisectors, all of them will also be intersecting at the same point. So in center, circumcenter, ortho center, all of those are also a single point in an equilateral triangle. So just by this information, we can easily solve this question. Since AD is perpendicular to BC, it is intersecting BC at the midpoint. That is, it is bisecting BC. So if that is the case, BD is going to be half of BC. And since this is equilateral, BC is the same as AB. So the ratio of AB by BD is 2:1. So this is one way of doing this. Even if you do not know that this perpendicular is going to be the perpendicular bisector for the equilateral triangle, you can still solve this very easily just by a knowledge of simple trigonometry. That take this triangle ABD. This is a right angle triangle. One of the angles is 60 degrees. We want to find the ratio of two sides. Ratio of BD to AB is cos of 60 degrees. So cos 60 is 1 by 2. So cos 60 is BD by AB. And if you know simple trigonometry, the value of cos 60 is 1 by 2. So you can easily find this ratio of AB by BD to be 2:1. So the option C. So whenever you have equilateral triangle, know that it has a lot of symmetries. So all the perpendicular bisectors, angle bisectors and medians, all of them are going to be the same thing. If you are given one, you can easily use the properties of other also in that same problem. Now in this question we are given that ABC is an isosceles triangle. So ABC, let's say AB is equal to AC and these two are 2A. And we are given that BC is A units. Now AD is perpendicular to BC and we have to find the length of AD. Now in an isosceles triangle, when we are drawing this perpendicular, you can see that there is a symmetry in this triangle. On the left of this perpendicular bisector, you have a side 2A. On the right also you have the same side. The angle that you see on the left is same as the angle on the right. The angle you see on the two sides of this perpendicular bisector are 90 degrees. So by symmetry only you can say that these two triangles are actually exactly same. These two are congruent triangles. So all three angles are same, all three sides are same. So since all three angles are same, from concepts of similar triangle also, you can see that all three angles, since all three angles here are same, these two are similar triangles, and since they are sharing one side, so that side is same, which means that these are congruent triangles. When we know that these are congruent triangles, that is side BD is equal to side CD, then we can say that the D is the midpoint of side BC. So BD and CD are A by 2. The whole side was A, D is the midpoint. So D is dividing it into A by 2 and A by 2. Now this is a right angle triangle. We know the hypotenuse is 2A. We know the base is A by 2. We can find the height. So 2A square, hypotenuse square is equal to height square plus base square. 2A square is equal to AD square plus A by 2 square. 4A square minus A square by 4. So this will come out to be 15 by 4 A square is equal to AD square. So 15 by 4 under root into A. So option B is the correct answer. So these are some of the questions related to triangles. As you saw that most of the questions included concepts of equilateral, isosceles or perpendicular bisectors, etc. So just remember these few concepts that we have taught in the previous video and you will be able to solve these questions very easily. See you in the next video.